Hello students, welcome to addition theorem for two events application problem. Let's get started. The question is given here. From 30 tickets marked with first 30 numerals, one is drawn at random. Find the chance or probability that the question number 1 is it is a multiple of 5 or 7. Question number 2 is it is a multiple of 3 or 7. Here, if you look here, there are 30 tickets. So, marked with the first 30 numerals. So, out of 30, one ticket is drawn. So, as per combination, so we know that out of 30 tickets, one ticket could be drawn in 37 ways. That's our total number of outcomes. So, we can say here. So, the next step, what I will do, I will start the solution. So, just underline, there are 30 tickets. So, marked with first 30 numerals out of 30. So, one ticket is drawn at random. Okay. So, the solution part is, first I will write total number of sample points. So, out of 30 tickets, one ticket could be drawn in 37 ways. 37 ways, that is, we can say here 37 value 37 equal to 30, since we know that as per combination rule NC1 equal to N. This is our total number of cases, we can say. Therefore, N of S equal to 30, which represents the number of sample points, okay, or 30. So this represents total number of cases. Total number of cases. After that, if you look question number 1, it is a multiple of 5 or 7, which means, so here R option you have to be observed. Multiple of 5 up to 30, we need to, okay, assign one event. For multiple of 7 up to 30, we need to assign one event, we can say here. So let us, again we have here in question number 2 also, so multiple of 3 or 7. Okay, what we do, let us take, let A comma, I can represent like A comma B comma C are three events denotes or represents the multiple of 5 comma 7 and 3 respectively. So let us suppose there are three events, namely ABC, which represents multiple of 5, multiple of 7 and multiple of 3. Now the next step what I will do, capital A is the event which contains multiples of 5. So 5, 10, I am writing in terms of set, again 15, 20, 25, finally 30, up to 30 means. So here only we will write the number of sample points in set A. Number of sample points in event A is, here total we have 6. N of A represents cardinal number, so N of A equal to 6. Similarly, we have B is the multiple of, okay, multiple of 7s, so which means 7, 14, 21, next is 28. This is the last one, so up to 30 case. So here the number of elements in capital B equal to 4. Now similarly, C is the set which represents multiple of 3. So multiples of 3 up to 30, 3, 6, 9. So 12, 15, again we have 18, 21, 24, 27 and 30 also. So total, so we have 3 plus 3, 6, 6 plus 3, 9 plus 1, 10. So then we can say the total number of sample points, okay, so or N of C equal to here 10. Now the next step is our first question we will concentrate. Okay, the first question is, he is asking to find the chance. Is asking us to find, here is asking us to find Find the chance. Probability of it is a multiple of 5 or 7. This are only the keyword for addition theorem for two events here. That is a keyword one can okay understand here. So here, so he is asking the first question, probability of, so 5 or 7. Now how do you write here? So in terms of events means probability of 5 represent for A, again R is there, R means union, 7 represents okay event B, so A union B. Now here apply addition theorem for events. So now applying addition theorem for events, so which means probability of event A plus probability of event B minus probability of A intersection B. This is called theorem statement of addition theorem for two events. But so we have here, for this is nothing but simply we can write here P of A means n of A by n of S as per the definition of a probability. So number of favorable cases by total number of cases. These cases are favorable cases, we can say favorable cases. Here this is also a favorable cases. This is also represents favorable cases. Okay, fine. Now here, so we have n of B means P of B means number of elements in B by total number of sample points. Here also n of A intersection B, which is divided by n of S. But what about A intersection B? Now since we have, if you look here, since A intersection B means common elements, is there any common elements? We need to check first. Here I have set A set B. So here 5 multiples, 6 numbers are there, again 7 multiples, okay, 4 numbers are there. So here there is no common element between A and B, which means what? Which means it is a empty set, which means A comma B are disjoint sets, are mutually exclusive. Disjoint sets are mutually exclusive. So in this case, what about n of intersection B? N of intersection B means it's a empty set, maybe denoted by or empty braces. So that okay, there is no elements. So answer is, so n of 5 means number of elements in empty set is 0. Directly I am writing 0. So the next step, what we will do, substitution of n of A. N of A means 6 by total number of sample points 30 plus B means 4 by 30 minus n of A intersection B, that is 0 by, so we can say here 30. So the total answer is 10 by 30. 6 plus 4 10, again by 30, 0 by 30 0. So this is equal to 1 by 3, which means probability of okay drawing a ticket which is a multiple of 5 or 7 is equal to 1 by 3. This is the first question answer. Now we'll go back and we'll check second question. It is a multiple of 3 or 7. Now we have results available already. So next step what we do, okay, now the second question, I want to find probability of 3 or 7. 3 or 7, which represents probability of drawing a ticket which is a multiple of 3 or 7. Maybe it may be a multiple of 3 or it may be a multiple of 7. So either multiple of 3 or either multiple of 7, the meaning. Okay, here 3 represents a C event, again union R means this is B, event B. Again apply addition theorem for two events. So if you apply addition theorem for two events, probability of C plus probability of event B minus probability of C intersection B as per the statement of addition theorem for two events. This is equal to, now probability definition is here n of C by n of S. Again when it comes to your second term, so n of B divided by n of S. So total number of sample points, favorable cases by total number of sample points. Similar pattern, n of C intersection B divided by n of S. Again what we do, we will check first C intersection B have any common elements or not. Go back previous page. So B intersection C or C intersection B, both are same. Now here 7 multiples, these are okay 4 elements. Okay, C contains 3 multiples, 10 elements. Look here, 7 14, there is no 14, directly 21. It is a common number between these two sets. So we can say here C remaining 28 not there. Okay, finally we can say now here, so we can say C intersection B equal to, we can say only one element common element 28. sorry 21, that is the common element 21. So this is called a singleton set. As you know the definition singleton, TON, singleton set, which means what? A set is said to be a singleton set which contains a single element. That's a basic definition. So number of elements in C intersection B equal to 1. Okay, quantity we are writing here, number of elements in C intersection B equal to 1. That's a common element between set B and set C. Okay, the next step, n of C. What about n of C? So we have n of C equal to, it's 10. So here numerator is 10 divided by denominator 30 plus sign. N of B, it's 4 divided by, again, so 30, it's a common denominator. N of C intersection B, it's 1 divided by 30. So totally, the total is here, numerator total is 14 minus 1, 13, 13 by 30, which means is probability of drawing, okay, a multiple of 3 or multiple of 7 is 13 by 30. Thank you students, thank you for watching.